Okay guys, let's start creating the loads. Going back up to this toolbar up here. Load page. Select load cases detail, add. Number one load case will be dead load. Some people prefer to put DL, which is fine. On this drop down, select dead, add. The next one will be live load, or LL if you prefer. Switch this to live, add. And then the last one will be, did we have a wind load? Dead live seismic. We have a seismic load. We have no snow to that. So seismic X and seismic Z. Close. So these are the four load types, load cases. For the dead load, select add. Have self weight in the negative y direction. Press add. We have as well a floor imposed pressure of 20 psf at the ground floor. Since we put plates on the ground floor, go to plate loads, pressure on full plate, and it was 20 psf, which is negative 0.02 kips 20 1 2 3, yeah, correct, in the global y direction, add. And then we have earth pressures to wall at phi angle 30 degrees, and we have 50 psf at first floor. The earth pressures we'll deal with after. The first floor was 50 psf, so you'll go with that 50 psf which is 0.05. Since we didn't model a floor on the first floor, you'll go to floor load. It's negative 0.05. Oops. Negative 0.05 global y, and define the y range. Is where exactly is this going to be located? Well, it's going to be between 12 and 13 feet in the air, and decided it was one-way distribution, so we highlight that. See, make sure it's default. We add that. For the seismic, so for the earth pressures, after doing the calculations, it came up to 0.42. We're going to use a hydrostatic we're going to use the hydrostatic values, and I want to look at it. It's going to be attacking here, which is in the x direction, positive. So make sure that you have your plate set up. Look at it in the 3D view. You see the plates are generated here. The direction of pressure will be global x. Interpolate along global axis, so it will be y. W1 is going to be 0.42. As calculation, we had to calculate that. Calculating K, gamma, and H is 12.5. K is going to be 1 plus sine 30 over 1 minus sine 30. And gamma is going to be 100 PCF. So when you work on that, you will get 0.42. W2 remains at 0 here. Add. The next, I'm going to choose these plates, and this is going to be negative 0.42. Same gx, global x direction, and interpolating the y-axis. Add. So this is positive z. And that is going to be the global z-axis, positive 0.42. I just select add. So then you have minus 0.42 will be these plates. Anytime you're lost, you can always look at this UCS here that will show you the direction, the global direction. So Z is in that direction. So if the hydrostatic soil pressure is pushing in this direction, which is against this, it's going to be negative. And if you understand? So this direction is going to be negative Z. So negative 0.42, and you add and you close. Alright, just to make sure that you let's assign a self-weight. The self-weight is the weight of the building itself, so you can just assign it to view, and that will turn red. This is the floor weight of the plates. So what we're going to do, once you see a question mark, means that the load was not assigned to anything, and this has to be assigned to the top plates. So what I will do is have the plate cursor, select the top plates with this highlighted, and just press assign to selected plates. Assign, yes. Now, if you find you're not seeing the loads being shown, go into your labels, scales, and trying to remember, this is supposed to be 21. Pressure was, I don't remember, pressure was 0.15. apply. Okay, right, so now we could see the different hydrostatic loads applied throughout. Seeing the self-weight load, seeing the ground floor load on the plate, and this is the first floor. Just looking for any other dead loads. There are the loads on the roof. There's a 10 psf at the roof. So let's, first of all, before we do anything, let's cut a section on the roof. Got it from a top view. So they said 10 psf at roof applies a member loads using tributary width. So these beams here will be 10 psf, and these middle beams will be 10 on this side and 10 on that side. So it's going to be 20 in total. So let's highlight that load, add. Go to member load because it's the beam members. Uniform force is going to be negative 0.01, and the global Y, add, and negative 0.02, add, close. So for 0.01, which will be the end beams, control. Right? Assign to selected beams, assign, yes. And then for the 20 kips, which will be in the middle, if you notice how easy it is for me to select. Once you understand the selecting process, it's easy to do. Assign, yes. You want these to be shown a little larger. Scales, 21 distribution. Okay, now time to create the live loads. So select live load, add seismic load. So the live loads that we have is 100 PSF on the ground, which is a plate load. So negative 0.1 global Y, add. What else we have? We have 60 PSF on the first floor, which is a floor load. Negative 0.06 global Y one-way distribution between 12 and the 13. Add. And then you have 15 PSF at the roof, which will be 15 and 30. So you have member load uniform 0.015, and it's going to be negative. Add, and this is going to be 3. Add, close. Live, everything is negative. Yeah, okay, that's fine. So this 100 PSF is ground floor on the plate. So get a side view plate. Let's select the top plate. Add it to the selected plates. Add, yes. And then this is on the first floor. This is the roof. Create a section. Look at the top view. So the 10 PSF is going to be on the outside. So not 10, sorry, 15 PSF. Assign to selected plane. And then we have this. Assign. Oh, that's good. So everything in blue is what I'm selecting here. So now to do the seismic in the X direction, they said for the seismic X and Z cases apply overall horizontal forces of 20 kips and 15 kips, 20 on the roof, 15 on the first floor. So let's create a section on the first floor. Creating a section card, looking at it from the top. So the nodes now it's 15, and the main nodes will be 15 nodes. So 15 divided by 15 is, so it's 1 kip per node in the X direction. So select seismic X, add nodal load in the FX is going to be 1, add, and in the Z direction it's going to be 1 as well. I'm going to add that, and that's for the first floor. So let's apply those. Oh, this is Z direction, so that's got to be deleted and added to the seismic Z, which is 1. Add, close. So we have 1 here, 1 here. These are for the first floor. So in the X direction, select nodes. Let me just edit this, see what's going on here. Node, may delete these, control, delete, add, nodal load is 1 kip, add, should say assign to beam. Alright, so we selected 15, pulling on the control button. So that's 5. That's 10. That's 15. In the x direction, assign to selected nodes, assign, yes. And then for seismic Z, add nodal load 1, add close, and assign to selected node, assign, yes. So x direction, looking at this. So x direction, z direction. So that works. So now for the roof. Create a section cut. Top view. It's now 10 o'clock, guys, so I'm sounding a little tired because I am. So on the roof level, it's 20 kips. So we're going to be conservative and assign 2 kips per node for 10 nodes. So it'll be 5 here and 5 here. So on the seismic X, add nodal 2, add close, seismic Z, nodal 2, XZ, add close. So using the nodes, node selector 1, 2, 3, 4, 5. Only 10 nodes we want, so 2 kips per node. And then assign to selected node, assign, yes. And then for seismic Z, same nodes are selected, assign, yes. So we're shaping up. So we have done the loads, and we have all the loads and them assigned. Let's minimize these. So we could create load combinations automatically. So go to commands, loading, automatic load combination. Using EISC table, public, generate loads, add, close. We could also create your own load combinations, but we will just use this. And like they are all located here. So these are different combination of loads. Different combinations of dead load plus live load, dead load, live load, dead load by itself, dead load, live load, seismic load. So a lot of combinations, right? So now we could do our analysis, and hopefully we don't get any error. So we come to analysis, no print, press add, close, go to analyze, run analysis, save. It will take a little bit to generate. Error in analysis. 100 errors. Let's see what's going on there. I think it may have been elastic modulus. Okay. So let's look at our property. These don't have steel assigned to it. So edit. steel, close. Edit. It's W10 by 100. Assign, close. Edit. 16 by 36. Assign, close. Edit. 40. Assign, close. Close. Alright. So save that. Let's run another analysis. Okay, so it's gonna work now. No warnings, so I don't need to go to the output file, but I would like to go to post-processing mode. Okay. All these labels are not necessary, so let's shift, go to labels. The structure itself, show center lines, show geometry, load and results, scales, labels. I don't need to see that. I don't know why it's showing all of that. Press OK. Updates. Alright, so two things you could do. You could look at the animation for deflection. It's kind of hard, but if you look closely, it's actually wobbling. Press escape. To look at these labels are really getting me mad. I need to get these labels off. So I don't know. Oh, there's a way to do that in the corner here. Turn off. Yes. Turn off. Label. Okay. Why are these labels here? I do not know. Okay, if you look at the deflection, holding on control and rolling your mouse, you can see it bending. But what we're interested in is looking at the stresses on the plate. So plate stress, select that. Look at and the MX local minimum to give you minimum and maximum values. Apply. Okay. So you can see here where the major stresses are on the plates. The hydrostatic stresses is not causing any major problems for the model. You can also generate reports. You can look at different load cases. Grouping for load tables by load case. Results table by load case. Selected. Press OK. If we zoom in, you get a generator report, and you can play around with this by selecting output displacements. If you want to see displacement reports, you can change the name on the logo with a graphic that you have stored somewhere. Steel design, you can do all checks and results, so on and so forth. Beam, you can see these forces applied by the stresses. You can see graphs that you would have learned in structural analysis classes. That's it. You have dead loads. You could change just to see. You can see the whole end flow. So that concludes my class. I hope it has been very informative for you. Leave a comment or send me an email at odaida@gmail.com. Good night. Have a blessed night. Bye.